Okay, that's fine. Once you, what I want you guys to do, when I was first learning how to do electron configurations, we learned the order, not necessarily by memorizing an energy diagram, but we did this diagonal rule kind of thing. We had to draw it out and draw these lines, and it told us the order to fill up. But really, the periodic table is a great map. If you follow it in order of the atomic numbers, it tells you exactly where to put things, okay? So let's do this. Let's look at the periodic table. And I don't know about you guys, but when I look at the periodic table, I see 4 rectangles. I see a rectangle here. I see kind of a long rectangle here. I see what really looks a little bit more like a square here, and then a skinny little rectangle down here. Can you guys picture the table that way? Mm-hmm. Okay. And did any of your Chem 1 teachers talk about a castle? No. Oh, yay. Goodness. Well, okay, this is periodic table kingdom. Really, my goodness. Okay, all right. So here's our little flags, right? Okay, and there's like a little guy up there, right? And this is really kind of like this. But this, oh, did I drop it? No, this needs to be a little taller. Okay, get this here. There we go. Okay, all right, there's our flag, okay? But this is lonely. It's going to kind of come over here, okay? So this is the way to look at the periodic table. All right, now, I call this the S tower, okay? And it's where the kings and queens live, and sometimes they just get a little snooty, okay? So that's why they're in the S tower. They, they're kind of their nickname, the S tower. Over here is the P tower. Guess who lives there?
The prince.
The princes and the princesses. Okay, all right. And then here, everybody's got to eat. So this is the dining hall, okay? And down here, what does every good castle have? It's got to have a moat, right? Okay, it's got to have a moat. Now, it's actually a very filthy moat, okay? So that's what's down here. And really, though, actually, the F stands for flock. It's a flocken moat, okay? And I know it sounds like I'm cursing at you, but really, there is a term, like moats aren't supposed to, they are supposed to be filthy, right? I mean, they're not supposed to be appetizing. Yeah. No one wants to go swimming in the moat, okay? And but if you were to be in charge of the water treatment plant, and you had to clean up that moat, there's actually a process called flocculation. Like it's real. That's a real word. Flocculation. Okay? And it's kind of cool. You guys will understand it because you take 2 chemicals, you react them together. I think it's aluminum phosphate and calcium hydroxide. You react them together and you actually get a precipitate. We've done that a lot in here, haven't we? Okay? But what's cool about this precipitate is instead of being like crystals that form together and sink, it actually kind of forms a gel. And the gel kind of, this actually is a real process used in water treatment. The really big particles of dirt or sticks or whatever, they just put them in a settling tank and they settle to the bottom, okay? What the flocculation does is you have that gel-like precipitate and it's hanging around in there, and all the finer dirt particles that tend to kind of stay suspended, when they run into that gel, they stick. And they keep sticking until that gel particle becomes heavy enough and it sinks. So it actually it's like a pool cleaner. You know what I mean? So it goes around, gets everything to stick to it, and it settles down. So flocculation. So this is the flocken filthy moat. How about that? Okay, now, if you think about this, I want you to look at the periodic table. Tell me about the S tower. My room is made of cinder blocks. Well, the periodic table is made of its own kind of blocks, the element blocks. So how many blocks wide is the S tower? 2. All right. How many blocks wide is the P tower? 6. Very good. How about the D?
10. And
how about the F? This is a little bit harder.
14.
It is 14. Now, some of you are like, can you count, buddy? So I want you to see this. This periodic table is kind of interesting. Do you see how there's a big gap in the numbers here?
Yeah.
Okay. Well, some periodic tables will put lanthanum here, 57 here, and then you have to jump down here, and there will be 14 elements. Some put, instead, they'll start this row with lanthanum like this one does, and they'll put lutetium up in there. Okay, so really this block is for one of the elements. So even though you're counting 15 down here, there's 14 elements in the F block. Does that make sense? Okay, now, I want you to look over here. Have you ever seen these numbers, 2, 6, 10, 14 before?
Yes.
Let's look in the electron configurations we've already done. I see the 2 and the 6. And look where I see the 2s. The 2s are always with the S's. The 6s are always with the P's. Okay? We haven't had an element yet where we have to do a D, but what would be the maximum number of electrons that can fit in a D? 10. And how about the F? Does that make sense?
Yep.
Okay. So what's kind of cool is if you look, I want to kind of break this down again, and I want to look over here. How much time has it been?
6 minutes.
Okay. If we look at sodium, okay, and we try to use the periodic table as a map, and some of you did this instinctively and some of you didn't, so I want to kind of get you on that boat. We're going to move helium over here, so we're going to pretend like that's where the 1 and the 2 are, okay? So the first and the second electron are going to be right here, and if we use this as a map, what row are we in? 1. And what tower is this called? S. So that's why we say 1s, and we can fit 2 electrons in there. So that's how we get the 1s2. Okay? And then just go in numerical order. 1, 2, okay, now this is going to be the 3rd and the 4th electron. So after 1s comes what? 2s. And that will fit 2 of them. So we had 2s2. After 4 does not come 11. We're not going to go straight down. After 4 comes 5. And so now we're over in this other area. It's still the second row, but we're in the P area, right? So this is 2P6. Everybody got that? And then after 10, find 11. That tells you where on the map to go. So here we go. We go over here. And so evidently after 2P comes 3, and what section is this? S, but we only needed 1 electron. Does that make sense? Yeah. Okay. All right.